Hello and welcome to the all of iGCSE Maths Paper 4 2025 edition. So very similar to the Paper 2 edition, I'm going to go through the key topics, I think about 9 topics in total that you need to understand for this calculator paper. So these are much more likely to appear on the calculator paper. Again, thank you for all the feedback about the exams. Right, without further ado, let's get on with 2 hours of revision. And on to, again, this kind of question. This is all question 1, and we're now looking at the estimate of a mean. Really, really important skill that you need to be able to do. Now, this is a 0580 course, so I'm going to do this manually without the help of a graphical calculator, but you can still use a scientific calculator for this. Now, as soon as I see estimate of mean, what we need to do is 2 extra rows or 2 extra columns. So I'm going to make this as neat as I can. Try to do this freehand, and there are 2 extra things that we need before we can work out anything. Now the first point is the midpoint, so I'm going to write that in, midpoint, and all that is, so in my column I'm going to find halfway between the boundaries here. So what's halfway between 40 and 60? That's going to be 50, 60 and 80, that's 70. If you need a formula for this, then the formula would be 60 plus 80 divided by 2. That's where it comes from. So if you prefer a formula, halfway between 80 and 90, be careful here. This is 85, so do pay attention when you do this. 90 and 100, that's going to be 95. And then here again, it changes slightly. So halfway between 100 and 150 is 125. Now what we're going to do, again, this is a standard procedure, you're going to see me do this a couple of times in this video, is we take this midpoint and times it by the frequency. So I tend to write m times f to represent that. Now some of these can actually be done mentally. So 50 times 6 is 300, 10 times 70 is 700. But some of these is easier to do on the calculator, so let's do it now. Okay, so I've worked out the 3 answers we need here. So 5,950, 7,980, and 3,750. So let's pop that in. Okay, so now I've got all that data. My next step, again, you're not going to get 4 marks for 3 here, is we need to add all these numbers together. So let's go to my calculator and do that now. Okay, so 18,680, add all those together. And now we've finally got everything that we need here. So to work out the estimate of mean, we take that total that we just worked out, so that's 18,680, and then we divide it by the total amount of students, so the total frequency, and we're actually told in the question, so you do use that, so we do over 200. Again, we're going to go back to the calculator for the last time. Okay, so 18,680 divided by 200, and then we get, well, a fraction, but let's simplify it to a decimal here. And we get 93.4. So we pop that in. So 93.4. Again, this is the whole value. So we get all 4 marks. Again, showing our working, finding those midpoints, finding the midpoints times frequency. Then we get the estimate of mean, and then we put down our final answer. Okay, and a new table here with different class intervals is completed as here. And on a histogram, so this is an important word here. If you're doing 0580, histograms are on your course. If you're doing 0607, they are not on your course. So only pay attention to this if you're doing 0580. And we're told on this histogram, the height of the bar between 40 and 90 is 17.2. That's going to be important later. And we need the height of the bar for 90 to 150. Now what I like to do here is make a new column. So I'm just going to pop this new column here, and I'm going to call this, hopefully this is a term you're aware with at home, and that is called frequency density. So I'm going to shorten that to FD. Now the way we work out frequency density is equal to the frequencies divided by class width. So we're going to work that out for both of these. If we do the one here, well, our frequency is 86. Now, what is that class width? Well, it's the difference between 90 and 40, which in this case is going to be 50. And if we do that on a calculator, again, I'm just going to do that on my calculator just here, then we get the answer of 1.72, which I'm going to write in here. And we do exactly the same process here. So we do 114 divided by, well, what's the difference between 150 and 90? Well, that's 60. And again, we can do this on a calculator. I'll make this a little quicker by doing it on the calculator here. And we get 1.9. So I'm going to put 1.9 here. Then we look at the actual height on the histogram here. So notice the height on the histogram is 17.2. So what do we do to 1.72 to get to 17.2? Well, we multiply by 10. So we need to do the same to work out the height for the other bar. So we have to multiply that by 10 as well. And that's an easy calculation to do here. 1.9 times 10, that gives us 19, which is going to be our answer for those 2 marks. Okay, so you can check all the answers. This comes from a really up-to-date paper on the May-June 2022 to give you really up-to-date insight on exactly how they are assessing you. Okay, and on to question 7. And we've got some information here in a frequency table and a very, very key topic on both iGCSE courses. This is a 0580 question, is the estimate of the mean mass. And this is a great opportunity for you to get 4 marks because it's always the same process. Now, what we're going to do here, and you've seen this previously, is we're going to make 2 extra columns. So I'm going to make 2 extra rows, underneath. And we're going to do it exactly the same way we did before. So our first row, if we go across, again, let's line this up so it's as neat as I can make it here, is we're going to work out what's called the midpoint of the category. So we want to find halfway between 0 and 10, that's going to be 5. Halfway between 10 and 20, that's going to be 15. Now be careful on the next one. So 20 to 25, that's 22.5. And now we've got between 25 and 40. If you don't spot this straight away, one way you can do to work this out is just do 40 plus 25 divided by 2. Well, that's going to give me 65 divided by 2. And then if we work that out, that's going to give us 32.5. Again, all of that you can do in your calculator as well. And then we've got between 40 and 50 is 45. And on 0580 questions, they will change that class width. So be careful for that. Now we're going to do the midpoint. So mid times the frequency. So we're going to times these together. Now some of these you can do quite easily. So 12 times 5 is equal to 60, like so. Let's use the calculator and work the rest out. Okay, so I've done all the calculations here. So what we're going to do is pop those over. So we've got 570 and 720. So let's pop those in. So 570 and 720. And the key thing with this process is just making sure that we're careful putting these numbers in. So 1,625 and 810. So 1,625 and 810. Now at this stage we need to work out the total here. So we need the total of all these numbers. Let's go back to the calculator and work that out. Okay, so let's just pop this in. So plus 720 plus 1,625 plus 810. That gives us 3,785. So that's going to be our total here. And then to work out this estimate, remember it's an estimate because we are using the midpoint of each category. We take that 3,785 and divide it by the total. Now the total is usually given in the question, so we're given 150. So that's going to be our last step. Let's work it out. So again, you can always use the control answer, works on most calculators here. We divide by 150, giving us, well, certainly a fraction, but then we can just change this to a decimal. Just give me one moment. Again, we get that. Control enter, and there we are. We get our final answer of 25.2. Generally with these, they do want you to do it to one decimal place. ... There we are. And so to one decimal place, this is 25.2. We're going to see this again, so this is a really, really important topic. Do get in the practice from this video because it comes up a lot on the 0580 paper. Right, now we need to draw a histogram. So this is 0580 only, so you will not get histograms if you are doing 0607. And essentially what we're going to do here is a so-called frequency density diagram. Now, in order to work out the frequency density, we've seen this formula before. This is equal to the frequency divided by the class width. So what we're going to do here is make another row here. I've left this on purpose for this question because it fits in quite nicely, like so. I'm going to call this FD for short, so frequency density. And all we're going to do is we're going to find the frequency, so the 12 here, and divide it by the width. So the width of this, so between 0 and 10, well, that's just going to be equal to 10, and 12 divided by 10, that's equal to 1.2. Likewise, if we do 38, again, the width here is also 10, so 38 divided by 10, that's equal to 3.8. Next one, well, 32, this time we've got 5 here, so be careful, the width does change. If you do 32 divided by 5, that's going to be equal to 6.4. And again, you do a similar process here. Notice I'm just putting the widths in. 50 divided by 15, that's equal to 3.3 recurring. Again, you can check this on your calculator. And then the last one, of course, is just going to be 1.8, 18 divided by 10. So this gives us the height of the bars. Remember, it's a histogram, so the bars go next to each other here because we're working with continuous data. So all we do is go over to the other side, and we're going to go between 0 and 10 because that's the width here, and we want to go up to 1.2. So go between 0 and 10. Now always look at the scale carefully here. Notice we're going up in 1.2s, 1.2, 1.4, 1.6, 1.82. So we need to draw a bar across here and downwards between 0 and 10. This one's 10 and 20, so go to between 10 and 20 up to 3.8. That's going to be here. So again, the bars are continuous, so they will be next to each other. We're going here between 10 and 20, so like so. This is where the width changes, so you have to be really careful here, between 20 and 25, and we want to go up to 6.4. So notice we want 25 here. The scale here go up in ones, so 21, 22, 23, 24, 25. We want to go up as far as 6.4. Now, the best thing to do here is not get dizzy when you're doing this. And then we want a bar that goes up like so to 6.4, across, and then downwards like so. Again, obviously in the exam, please use a ruler. That will make it as accurate as possible. Then we've got between 25 and 40, which is 3.3 recurring. So I'm going to go as far as 40 here. Now 3.3 recurring, this is 3.2, this is 3.4. It's going to be halfway in between. Don't worry if you don't get it completely accurate, but just do the best that you can to make the best histogram possible. You do get a whacking 4 marks for this, so it's worth spending the time over. And then the last part of the question, 40 to 50 at 1.8. Well, 1.8 is going to be here, and then we go straight across to 50 and downwards. Please don't spend time in the exam shading those in. That is all you need to do, of course, with a ruler to get all 4 marks. Over to the next question, which is a cumulative frequency table. And the way I like to call this is a so-called running total. So I'm going to show you what I mean by that. We also have to check the class widths to make sure they correspond to the table. So what do I mean by this? Well, we start with 12 first of all, so that doesn't change. And then we're doing this running total. So we keep adding these numbers on. What do I mean by this? Well, 12 plus 38 is equal to 50. So the next one will be equal to 50. Then we've got our 50. We add on 32 to it. That gives us 82. So we just keep adding these results on. Then we've got 82 plus 50. That's equal to 132. And then the last one, 132 plus 18 is 150. And a really good double check to do here is this number should be equal to the total frequency. If we go back, the total frequency is 150, so we've got a good chance of this being the right answer. Last part of this question, so a bit of interpretation here. Find a percentage of children with a mass greater than 10 kilos. Well, notice we've only got 12 people here less than 10 kilos. So we need to do 150 minus 12. If we do that, we get 138. And we want to work out the percentage the 138 is of the total frequency. So then we divide this by 150 and then times by 100, the standard formula for working out a percentage. So let's go to the calculator and work it out. So all we do is just type in 138. Again, you can use the fraction button if you so wish. Yeah, let's use the fraction button. So here we are, 138. Make sure you definitely type it in the right place. That is very important. And then we go 150. That's it, times by 100. And that gives us 92 exactly. So we just pop over 92, and that's going to be 92%. No rounding involved in this question. So you can have a look through the answers. You can look at the widths and the heights of the frequency density graph, the histogram as well. Again, this comes from a typical 0580 paper 4 question, so make sure you are getting all these marks. First of all, we've got the classic table of values here, and what we need to do is complete the table for both these functions. So y equals 2 to the power of x, and y equals 14 minus x squared. So what we need to do in order to fill out the table is wherever we see an x, we need to put these following numbers in. So 0 and 4 for the gaps here, and likewise at the bottom here. So let me show you how we do this. So if we're doing x is 0 here, so wherever I see an x, I'm going to put a 0. And so we get y is equal to 2 to the power of 0. And again, you can use your calculator to work this out as well, of course, and that's equal to 1. So we pop 1 in there. And now we go to the 4, so this missing gap here. And now we do the same thing. So we look at our expression or equation here. Wherever we see an x, we're going to put a 4. So we do y is equal to 2 to the power of 4. Again, you can use your calculator to work this out. Remember, this means the same as 2 times 2 times 2 times 2. And then that gives you 16. So we pop in 16 like so. And here we have a negative quadratic. Now, what do I mean by quadratic? Well, there's an x squared in here as well. And this is where we have to be a little bit careful with BIDMAS when we work these out. Right, so we're going to do the same technique that we did above. So we've got x is equal to 0. So wherever I see an x, I'm going to put a 0. So we get y equals 14 minus 0 squared. Okay, that's going to be quite nice because anything times 0 is just 0. So this becomes then just 14. So we pop 14 like so. And here we do this in a very similar way. So I'm going to copy out this expression. And wherever I see an x, I'm going to put a 4 this time. So y is equal to 14 minus 4 squared. And this is where BIDMAS really does come in. So what we do at this point is we do the indices first. Remember, BIDMAS, so quick reminder on this. So we are going to do the indices, the small numbers first, then we do the subtraction afterwards. So 4 squared is equal to 16. And 14 minus 16, that's equal to minus 2. So we pop that in to our table like so. And now this is very typical. So once they've given you a function or two functions, you need to draw the graph of it. Now remember, the scale has been done for you. So if you find a point that goes off the scale, then something probably has gone wrong. Now, what are we actually going to plot here? Well, actually, these are ordered pairs, i.e. coordinates. So this one here, for example, is 0, 1. This is going to be 1, 2. This is going to be 2, 4. You get the idea here, 3, 8, and then 4, 16. So all they want us to do here, and you can see a whopping 6 marks of the whole thing here, is just to plot these coordinates on the grid. Now, because we've got two functions, I'm going to do it in two colours. Let's start, of course, with 0, 1. So we have to be very careful exactly where 1 is here. Remember, halfway between 0 and 2. Remember, along the corridor up the stairs. And we've got 1, 2. Look at the scale. So 1 along and 2 upwards. And you have to be as accurate as possible with this. So 2 along. And my eyes are probably going to go very dizzy here. But we do need to be accurate. So that comes to here. Then we've got 3, 8. So 3 along. And just making sure I get exactly the right point here. I think it's there. Yep, I'm happy with that. And then finally we get 4, 16. So we get 4 along and 16, which is very convenient because that's going to be the very last point here at the top. And what we now need to do is draw this up with a smooth curve. That's really, really important. So I'm going to write that on the side here. You must be joining this up with a smooth curve. This is not dot to dot, not joining up the lines here one at a time. We're going to join this up in a smooth curve. Now, I just noticed that point disappeared. That's annoying. So we're going to start here and we're going to do a smooth curve all the way through. This is more difficult to do online. Just make sure you do not lift your pen off the paper as you do this and go through all the points. If you need to do this 2 or 3 times in the exam, then by all means, please do that. So let's see if I can do this first time. Not too bad. Oh, I'm going to leave my pen off. Okay, but please don't do that if you're doing it at home. And that's pretty smooth. Not the very best curve that I could draw here, but certainly not too bad. And what we're going to do now, and I'll do this in a different color, let's do this in black, is this one here. So again, we turn these into ordered pairs, coordinates. So we have 1, 13, 2, 10, 3, 5, and then 4 minus 2. And notice all those coordinates do fit onto the graph, so it does make sense. Right, you've got 0, 14, so along the corridor up the stairs. That's going to be here. Then along the corridor, this is 1, and then up to 13. So this is going to make me dizzy, I'm sure. This line here, and we want halfway. So I want there. Try and make sure I get exactly halfway. There we are. And then we've got 2 10s, so 2 along and 10 upwards. I can just feel you all fast forwarding this bit until it's actually finished. In the exam, you need to be careful. So 3 5. So 3 and then 5. So that's going to be... God, I find this hard to do online. Hopefully having more luck at home. 3 5 and then 4 minus 2, which is a nice point to have. Again, we need that smooth curve. So get your arm ready. Make sure you've got no cramp in your arm. And then here we go. Smooth curve. Smooth curve. Okay, this is not so good. This is not so good. Needs to be smoother than this, but it's okay. It's certainly not too bad. Again, you'll see the mark scheme right at the end of this question as well. You can see it wobbled here. And you can see I did this in a one take, yeah? So you get practice at this, you rub it out, you try it again, but it should be good enough for the questions we're going to do. So we've drawn both functions onto the graph. And now what's very normal on these kind of questions is some kind of interpretation. So we're going to use our graphs to solve the following equations. First of all, 2 to the power of x is equal to 12. Now notice, whenever you get a question like this, you already have a function you've already drawn. So notice we've drawn this, and we want to see when this is equal to 12. Or in other words, when y is equal to 12. Okay, this is essentially what this means. Now, what does the line y equal 12 look like? Well, that is a horizontal line that goes across at 12. So you can see lots of colours here. It's going to go to red this time. So you want to draw a horizontal line all the way across, because we may need it later on, who knows. And what we do at this point is we want to find the intersection point. So the whole point of these questions, remember this graph here, let me put this in purple again, so 2 to the power of x, and this one here, let me put that in red, is 12. This is obviously y equals 2, and then the black one that we did here, which we'll obviously use a bit later on, so this is going to be 14 minus x squared. So for this question, 2 to the power of x is equal to 12. What it's looking for is this intersection point, which I'm going to do in another colour. I'm going to do this in yellow. And what it wants us to do here is read off the x values. So what we're going to do is we're going to go downwards. So we're going to go downwards here. And then we're going to read off this coordinate from the graph. So we need to work out what scale this is going along in. So let's have a look at this, probably in point ones. 1, 2, 3, 4, 5, 7, 8, 9, 10. Yeah, it's going up in point ones. Makes our life easy. So 3.1, 3.2, 3.3, 3.4, 3.5, 3.6. So I'm reading this off to be 3.6. So then we'd write in our answer of 3.6. Now if we look at the answers here, it gives us, we don't really accurately here, between 3.5 and 3.7. This is a question I often get asked, what about if I don't get quite right, I get 3.55 or 3.5 or 3.7? You can see that you get any of the answers between these numbers. So as long as you get a number between 3.5 and 3.7, including those numbers, then you will get the entire mark there. And of course 3.6 being the best answer because it's halfway in between. This one here, we want to find when this function is equal to this function. Now we do this in a very similar way to how we did the previous question. So we want to see when the black graph, the 14 minus x squared, that's the right hand side of this equation, is equal to the left hand side of the equation, which is 2 to the power of x. So what this is saying, in other words, it wants you to actually work out where they cross and then read off the x values. So I'm going to pop this down, and then let's do exactly the same process here. So we've got 2.1, 2.2, 2.3, 4, 2.5, 2.6, 2.7. So I'm going to say that is equal to 2.7. And let's just pop that in as our answer. And we can quickly check how accurate I've been here. So 2.7. And it goes between 2.65 and 2.8. So we lie within that range. So that's absolutely fine. We still get that full mark there. Now for question D, on the grid, we need to draw the line from the point 4,2 that has a gradient of -4. So what a gradient means, remember, means the steepness of the line. And I'll show you where the -4 comes in a little bit later on our graph. So steepness of line. So let's start with 4,2. So let's find 4,2 on here. So 4 along and 2 upwards. That's going to be here. And we need to draw that line that has a gradient of -4. Right. So to have a gradient of -4, we need to go in this direction. So this line has a negative gradient, this line has a positive gradient, and we need to go 1 along and 4 upwards. So that's essentially what a negative gradient means. So what does this look like? Well, the easiest way to do this is just go 1 along, let's go 1 along, and then go 4 upwards. So we start at 2, and we want to go to 6. I'm going to put this in as a dotted line so you can see where this is coming from. So go 2 and then up to 6, like so. And just to confirm that I'm doing this correctly, I'm going to do one more point. So we're going to go along 1 from 6. And you've always got a ruler in the exam, so please use it. And then we go upwards. You get this sort of staircase idea as we go along. So that's quite nice. It hits that point there. And we'll talk about that in a moment. So all I'm going to do at this point is I'm going to just join up the points here, and it will continue in the same direction. So again, you want to do this with a ruler. I do not have a ruler here. Again, but you want to keep the same gradient as you're going upwards. Okay, so this needs to be done with a ruler. That wasn't the best try in the world, but we are going to talk about this point where it just touches. You see, it just touches that black curve that we talked about earlier in this problem. So it wants you to draw a straight line like this, and it wants you to recognize that whenever a line just touches a curve, that is called a tangent. So the straight line that we just drew is a tangent to that quadratic graph for a 1 mark, and then it wants us to identify the point where it just touches, and that is the point there, 210. So we just pop in 210 there. And this is really important topic, particularly if you do differentiation, which is also on the 0580 course. Again, if you haven't checked out my all of differentiation video, which goes into tangents in more detail, then please do check that out. It's just in the link above, and you'll see it in the description below as well, where it goes through that in more detail. But today I'm just focusing on just the table of values. Right, so you can check your answers, you can see where you pick up all the marks. This is one of these topics that when it does appear, and it appears quite often on paper 4, not every time, but pretty often, you can see the ton of marks you get here, 6, 8, 10, 12, 13, 15 marks. For, as you can see, pretty straightforward process. It takes care, but it is a straightforward process, and you need to be getting those marks to get those higher grades that you deserve. on distance time graphs and speed time graphs for the iGCSE Maths 0580 course. Right, let's get started. So we have a diagram here, which is a speed time graph. It's often quite useful here to underline whether you have a speed time graph or a distance time graph. That's going to change what we're going to do in the question. And it's of the first 15 seconds of a car journey. Now, generally a 1-mark question is exactly what they ask here, which is for the acceleration. So for a speed time graph, they could ask for the acceleration of the car. So all I'm going to do here is essentially work out the gradient. So if I see acceleration for a speed time graph, I'm going to work out the gradient of that particular part of the graph. So in this case, we're looking at the first 5 seconds. So I've got 5 seconds here. And if I look at the height here, that's going to be equal to 14. So to work out the gradient here, all we do, remember, is the change in y over the change in x. So our change in y, so the height of this is 14. And then the length of this is equal to 5. So we get 14 divided by 5. I'm going to put that as a decimal, which is 2.8. Again, you can check that on your calculator. Looking through some of the mark schemes, sometimes they want you to simplify and sometimes they don't. So on the safe side here, I'm going to put this as a decimal. Now, the second question is also very, very typical, which is the distance traveled. So as soon as I see the distance traveled on a speed time graph, I'm looking for the area under the graph. And you're going to see this idea again and again in this video. So how do we work out the area under the graph here? Well, we have a triangle and we have a rectangle. So to work out the area of the rectangle, notice here that the length of my rectangle is the difference between 5 and 15. So that is 10. The height has remained the same, so that's going to be 14. So to work out the area of this rectangle, we do 14 times 10, which is equal to 140. And if you want to work out the area of the triangle, notice here we're working out the area, not the gradient. So I just want to find the area of the triangle, and that's equal to 14 times 5, so base times height divided by 2. And again, you can use your calculator to work this out. I'm going to do this non-calculator style. So 14 divided by 2 is 7. 7 times 5 is 35. So to work out the total area under the graph, so the entire 15 seconds, we just do 140. So this answer here plus 35, and that gives us 175 meters. Generally in these particular questions, they do give you the units to put into the answer, so you don't have to worry too much. However, you are going to see some more advanced questions where you need to work between meters per second, kilometers per hour, and so on. So you can see the answers there for your 3 marks. This is a very standard question I'm starting with in this particular video, and you can see the working needed. Okay, on to our next question, which is a bit more difficult. So again, we have a speed time graph, but I'm going to be highlighting that or underlining that in the exam. And we have the graph here, which is kind of unfinished, but we'll talk about that. The car starts and rests, so 0, 0, and accelerates at a uniform rate. And in the iGCSE, it'll always be uniform for 15 seconds before reaching a constant speed of 30 meters per second. So again, that 1-mark question, which is very, very typical, calculate the acceleration for the first 15 seconds. Well, again, as soon as I see acceleration here, I'm thinking gradient of the first part of the graph, almost always a triangle. So we have here at 15 and we have here at 30. So all we need to do here is change in y over change in x. So we've got the 30 divided by 15. And again, that's going to give us the answer of 2 meters per second squared. Notice that's always a hint in the question here. If we have meters per second squared, that's always going to be an acceleration. Whereas if we're looking at a speed, that's going to be meters per second. And I like this next question. It's really getting you thinking about what's going on here. After t minutes, and they bold letters for a reason here. So we're working now in minutes here, and the total distance traveled is 45 kilometers. Also very, very important, and we want to find the value of t. Well, the first thing to realize here is 45 kilometers, that's the same as 45,000 meters. So we're going to come to that in a moment. My first thought here is, well, if you want to find the total distance travelled, like in the previous question, it's the area under the graph. Now you're probably thinking, well, we don't have two distinct shapes, but let's just work out what we can so far. So we're going to work out the area of this. So we've got a triangle. Remember, it's base times height divided by 2. So we're going to do 30 times 15 divided by 2 to work out the area of this triangle. Again, you can pop this into your calculator or a bit of non-calculator work here, and that's going to give you 225. Now let's think about units here, again important in physics and science as well. We have meters per second here, we have seconds, so this must be in meters, and that's really, really important. So what we want to find is the entire area here is equal to 45,000 kilometers. So the first thing I'm going to do is take away this 225 meters from 45,000. So I then just need to work out the area of the rectangle. So I'm going to do 45,000 meters because that's my total, and take away 225 meters. And that gives me 44,775 meters. Right, so I want this area under the graph here to be equal to 44,775 meters. We know the height is 30 here, so essentially what I'm saying to myself is 30 times something, so that's going to be the length here, is equal to 44,775 meters. Notice we're working in seconds and meters for the moment. So to work out this thing, what's the opposite of timesing by 30? Well, divide by 30 on both sides. So this thing I'm looking for, the length here, is equal to 44,775 divided by 30. And if we pop that into our calculator, we get 1,492.5. Again, think about the units here. This is going to be equal to seconds. Okay, so what I've worked out here, just to show visually what's going on, I've worked out that this length here, so this here is going to be equal to 1,492.5 seconds. Okay, perfect. So what we can do now, because remember we want to find the value of t in minutes, that's why I underlined this. So we need to convert 1,492.5 seconds into minutes. Now how many seconds are there in a minute? Well, we need to divide by 60. So if we divide that by 60 here, we then get our answer of 24.875 minutes. That's not the final answer because we've got this extra 15 seconds here as well. So to work out t, we need the 24.875, and then in minutes add on this extra 15 seconds. Well, 15 seconds here is a quarter of a minute. Quarter of a minute is 0.25 minutes. Add those together and we get to our final answer of 25.125 minutes. For our final answer, so I'm just going to pop down here. Now my temptation here is just to leave it as an exact value because I don't think there's any need for rounding at this particular point. This is a much more sort of complicated question. You can see here, this is question 15, and really gets you thinking about, I know I need to find the area under the graph. I'm kind of working backwards to then find the time. And you can see the working here. I've taken this approach, so this one here, and then use that to then work out what I need to get to 25.125. Right, on to our next question. So this is question 5 here. And again, we've got a speed time graph. I do promise you there will be a distance time graph in this video. For two vehicles, we've got a car and a bus. So notice we've got here the bus traveling at a constant velocity, a constant speed here, which we'll find out a bit later. And again, that 1 mark question, as I've told you, always comes up. Just be a little bit careful in this case. So acceleration, that means we're looking for gradient, but we have to be careful here because we're considering this part of the graph. So the temptation is to use 24 here, but we don't want to use 24. We need to use this length here. Well, we've got 24 minus 10. That's equal to 14. This bottom part is here equal to 18. So our gradient here will be equal to 14 divided by 18. Biggest mistake that's made in this kind of question, again, you can simplify the fraction, but I'm going to leave it as 14 over 18. But the biggest mistake is that people take 24 here rather than this length 14. So watch out for that 1 mark. On to part 2. So in the first 40 seconds, the car travelled 134 metres more than the bus, and we want to work out the constant speed v of the bus. So we're going to form an equation here where we want to equal the car distance to the bus distance. So first of all, how far did the bus go? Well, we just need to work out the area of this rectangle. So I just pop this in here. So what's an expression to represent this? Well, the bottom of this rectangle is 40. The height is equal to v. So the total distance travelled will be 40 times v. That gives you the area of that particular rectangle. Hopefully I can delete this so you can see the car a bit later on. And we're told in the question, the car travelled more than the bus. So we need to add on 134 here to equal the total distance travelled by the car. Now, next question is, how do we work out the area for the car here? Well, we divide it into 2 separate shapes. So we've got here, we can use this as a trapezium or a triangle and a rectangle. So you can take that approach and you'll see that in the mark scheme. But what I would recommend to do, as long as you're happy with this, is to take the area of the entire rectangle. So let me just show you what I mean here. So for the car here, so work out the area here and then subtract, so using the subtraction method to take away this triangle here. So I'm going to take this more sophisticated approach. If we do this, we get, well, 40 times 24 is the area of the entire rectangle, and then we're going to minus the area of this particular triangle. Now, we already worked out the dimensions in the previous question. This is 14, this is 18, so we're going to take away 14 times 18 divided by 2. I think this is a smoother way to get to our equation. So remember, the left-hand side represents the total the total travelled by the bus. The right-hand side does the car. Now, let's just tidy this up slightly. So we've got 40v plus 134. 40 times 24 is 960. And this here is equal to minus 124. And now we've just got an equation to solve for v. So if we work through our process here, first of all, let's tidy up the right-hand side. So 960 minus 124, 960 minus 124 is equal to 836. Hopefully you're now in comfortable territory. It's like, nice two-step equation, very, very good. Then we've got a plus 134, so the opposite of that is minus 134 on both sides. This cancels, this gives us 40v, and then 836 minus 134 is equal to 702. Just make sure we've done this all correctly. And then we divide by 40. And that gives us 17.5 for our final answer. Perfect. I think there's a mistake made somewhere here. This should be 700. Just check my working as you go through. But you'll get to the answer here of 17.5. And the second part of the question is not really related to what we've seen so far, which is a train takes 10 minutes and 30 seconds to travel 16,240 meters. Notice the units here, seconds and meters, and we want the average speed of the train in kilometers per hour. I've said sometimes they want you to transfer between meters per second and kilometers per hour. Now, some people here just learn the rule off by heart to convert between it. What I find is students often forget that during the exam. So my approach here instead would be, well, I've got 10 minutes and 30 seconds. So that's 10.5 minutes. Remember, 30 seconds is half a minute. And I'm just going to convert that into hours. So the way that we do this is just divide by 60. And you have a calculator in the exam, so there's no reason why we can't sort of exploit that and use it. So we get 0.175 hours. Then we've got 16,240 meters. We want to convert that to kilometers, so we divide by 1,000. Remember, there are 1,000 meters in a kilometer, and if we divide that, we get 16.24 kilometers. And now this is just a very straightforward use of the speed distance time rule. So we want to find the speed, so we need to do distance divided by time. So speed is equal to 16.24 divided by 0.175. Again, let your calculator here do the rest for you. So you got 16.24 divided by 0.175, and that then gives us 92.8. By doing it in this approach, and that gives us all 3 marks here, that then guarantees we've got the right units for the questions. So rather than learning some rule, which obviously you can use here, what's more effective usually in an exam setting is convert to hours, convert to kilometers, and then you can use the formulae, safe in the knowledge you don't have to do any changing of units later on. Okay, so those are the answers for the questions you've just seen. And if this content has been helping you so far, then please do think about subscribing to the channel, because you'll find tons of iGCSE maths videos. I think it's up to about 120 videos to cover all things iGCSE maths 0580 and 0607. Hello and welcome to another Ginger Mathematician video. We're going to go through all you need to know on percentage calculations coming up on most of the papers, particularly paper 4. Right, let's get started. So Alana pays a weekly rent of $255 for her apartment, and the price of this weekly rent is 2% higher than 1 year ago. And we need to find the price of her weekly rent 1 year ago. And I always use the tense of the question here to help me. So we've got ago, so this is in the past. So essentially we want to work out what it was before, and she is now paying this particular weekly rent. So we know then that if we've got 100% and we add 2% to this, well, we have 102%. So currently Alana is paying 102% of the rent that it was 1 year ago. So the way I like to format this, and you'll see this for lots of questions in this video, is I write down what I have. So 102% is equal to $255. And what we want to find is that original amount, that original 100% from before. So by structuring it in such a way, it then lends very nicely to the calculations that we're going to do. So we need an intermediary step. We need a step in the middle. And the way we can do this is a so-called unitary method. So I'm going to divide both sides by 102. If I do that, well, 102 divided by 102 is equal to 1. So the key thing here is to try and get it into 1%, and then we can then work out 100%. So if I want to go from 1 to 100, well, I just times it by 100, doing the same on both sides. So my calculation here to actually work out the correct answer is to take the $255, get that 1% by dividing by 102, and then multiplying by 100. Now, you'll really need your calculator for this video because we're going to do tons of work using it, so make sure you have it ready at home. Okay, so I've got my calculator here, and I'm just going to go through the operations we've just done. So we do 255, so 255 divided by 102, and then we're going to take that and times by 100, giving us our final answer of 250. Again, you don't need to write down the intermediary step if you don't need to, but it was 2.5 if you need that there as well. So our final answer here is $250. Always do a common sense check in this kind of question. So she had a rent of $250. It's now 2% higher, which is then $255. So if you're never sure in the exam, you can always check by going logically through the question to make sure you're getting this correct answer of $250. Now, Alana, unfortunately, can only pay 1 full year's rent in advance. Now, 1 year is 52 weeks. That's important to note. She will receive a discount of 3% on each of the weekly rent of $255. To calculate the cost of paying the full year's rent in advance. So the first thing I'm going to do here is I'm going to decrease, as we're going to assume she gets a discount, decrease $255 by 3%. Now, there's a couple of different ways that we can do this. The method I like to use here is if you've got 100% and we've got a decrease of 3%, so taking away 3%, that leaves us with 97%, and then converting that to a decimal, which sometimes calculators you don't need to do this with, you get 0.97. So a really easy way of working this out using what we call the multiplier, this 0.97, is just take the 255 and then multiply by 0.97. So I'm going to just do that on my small calculator here. If we do that, we're going to get 247.35 and there's no ... because it's an exact value, and 1 year is 52 weeks. So notice that key underlining here of the question is really useful. So the cost is going to be this discounted rent of $247.35, and then we're going to multiply by 52 weeks. Now, good thing about keeping it in your calculator here is we can just press times 52. It will take the previous answer and use that. And if we do that, we're going to get then the decimal of 12,000, just write this down, 12,862.2. Now, whenever you're doing a money calculation style question, make sure when we're writing this, $12,862.20. We should always be working with 2 decimal places whenever we do a money calculation. And we move on to a more problem-solving style question here. So 1 week, Bev, new person here, Bev, she earns X amount of dollars. She spends a quarter of these earnings on rent and 2/9 on food. And then she spends 1/3 of the remaining money. Now this is in bold, so whenever I see something in bold on the iGCSE question, I'm really going to pay attention to that. She spends that remaining money, or 1/3 of it, on clothes and then saves the rest. She saves $152, work out the value of X. So I'm going to ignore the X for the time being here, but I'm just going to be working out how much money she's taking off and what fraction is actually being saved here. So my focus here is to work out the fraction to be saved. And I'll talk through that at the moment. So say you've got a full amount of money here, and we're going to take off a quarter and 2/9. So the first thing I want to do here is work out a quarter plus 2/9. Now, you could of course use non-calculator methods here, but this is a calculator question. So all I'm going to do on my calculator here is simply type in 1/4 plus 2/9 and see what happens. This is something I really encourage you to do on any calculator, any scientific calculator. So I'm going to use the fraction button here. I go 1/4. Of course, on a non-calculator paper, you'd have to do this manually. But if we have the calculator, why not let us do the simplifying for us? So look, go equals, it'll give you that fraction. It'll give you that directly of 17/36. So whenever you are doing a fraction question with calculators available and it says you can use it, do use it. It will save you lots of time in the exam. Notice it's only a 3-mark question, so you need to save time where you can. So if she's spending then 17/36 of this X, then what's remaining, I'm using the word in the question here, well, we take 17/36 away from a whole one. And if we do that, well, we can do that in our head here. We get 19 over 36. Again, remember, 1 is the same here as 36 over 36. So we have 19 over 36 remaining, and she spends 1/3 of this on clothes. So she'll be left over with 2/3 of this remaining. So the amount that she saves is equal to 2/3 of this 19 over 36. Now remember, whenever we talk about of in mathematics, we're talking about multiplication. We're talking about multiplying and timesing. So we get 2/3 times 19 over 36. Again, we can use our calculator to do this for us. And if we pop that into the calculator, so again, just using my calculator here, there is no need to do non-calculator methods for a question like this. And if we pop it in, we then get 19 over 54. So this is the really important fraction. She saves 19/54 of this particular x. However, we know what 19 over 54 is equal to, because we're told she saves $152. Therefore, we know 19 out of 54, that's going to be equivalent to the $152. But we want to work out the whole amount. We want to work out 54 out of 54, a whole one. Notice this process I used actually in the very first question in this particular extended question. So again, how do we get to this? Well, we can do it in the same way we did before. If we divide by 19 on both sides, this is so-called a unitary method, we can then work out, well, this cancels, we get 1 out of 54, and that will give us a certain amount. And then what do we do to 1 out of 54 to get 54 out of 54? Well, we multiply by 54, making sure we do the same process on both sides. So this is now where the calculator comes in. We've set this up in this 3-stage process, and now we can just work out the answer. Okay, so all we need to do at this point is type in what we've written. So we get 152 divided by 19, and then we are going to times by 54, giving us our final answer of $432. Again, we can write in the intermediary step if we need to show the working, but this amount of working is more than enough to get all the marks. You're going to see this 3-step process again and again and again in this video. It's one of your big tools for any percentages question. And on to part D, so really testing a lot of different skills here. So Kaga invests $500 for 5 years at a rate of Y% per year simple interest. So it's the first time we've seen interest in this video. Remember, simple interest means, again, it's not compounded. So we don't include the extra interest in our next lot of interest. Again, you're going to see this in a lot of different questions. And the value of Kaga's investment at the end of this 5 years is $530.75. Find the value of Y. So the first thing we want to work out here is the total interest that she earns. And the way that we do that is we take the final amount and we take away the original amount, the $500. If we do that, we get then $30.75. And then we want to look at the interest that Kara makes per year. Well, how many years was this investment for? This was for 5 years. So we take our answer and we're going to divide it by 5 then to work out how much interest she made in a particular year. So 30.75 divided by 5, and we get $6.15. So once we know that's the amount of interest that she makes in 1 year, we want to work out the percentage that is increasing by. The way we would do this, so we're going to find this percentage interest, and the way we will do this is we'll take the 6.15, the answer we got before, divided by original, so that's going to be 500, and then times by 100 to ensure we get a percentage at the end. So let's pop it in the calculator this time and see what we get. So we've got our calculator here, we pop it in. So again, use that fraction button. It's very, very useful. So 6.15 divided by the total amount, which was 500 here. Again, times by 100. Don't feel like you have to use non-calculator methods. Again, as long as you're happy using the calculator, understand what you're doing, it's going to speed you up. So we get our final answer here of 1.23%. So we pop in our answer of 1.23. Notice our answers in this entire question, we're generally getting either whole numbers or just strictly 2 decimal places. That's usually a good sign that you're on the right track with these questions. Okay, so you can check all the answers that I've gone through here. This is a really good meaty question. You can see you're getting 10 marks on this question. And this could really make a difference between a B and an A grade or an A and an A star. Okay, and on to our next question. So Sachin earns $63,000 per year before paying tax, and he pays tax on his earnings at a rate of 16%. We need to work out the amount that Sachin has after paying tax. So essentially he's got this $63,000 and then we want to reduce, because remember tax is a reduction of 16%. So to translate this into a standard calculation, we want to reduce $63,000 by 16%. So in order to work this out, again, we work out in a similar way to our previous question. So we have 100%. And we want to minus 16%. So how much percent will he be left with? Well, that's going to be 84%. What will that be as a decimal? Well, that's going to be 0.84. So to make our calculation nice and straightforward, all we need to do here is 63,000 and then multiply by 0.84 to work out how much he gets after tax. So we go 63,000 times 0.84, giving us our final answer of 52,920. So we pop that in. So Britta here has a slightly different situation. So she has paid $60,480 per year after paying tax at a rate of 16%. And we want to work out the amount that she has before paying that particular tax. So notice in this case, we've already got this 0.84 from the previous question, that this 84% is equal to the 60,480. And what we want to find here is that original amount. So we want to find the 100% that she had before paying tax. Now, as soon as we've got that set up, just like we've seen in the previous question, what we can do now is work through this 3-step procedure. So what do we do to both sides at this point? Well, we're going to divide by 84 on both sides. That then gives us 1%. And then what do we do to 1 to get to 100? Then times by 100. So again, making sure we do the same to both sides, getting that 1% from the original calculation and then working that out, that original. Remember, we're looking for before paying tax, so we're going into the past. All right, let's go to my calculator and work this out. Okay, so we followed the instructions from the question. So we've got 60,480. We're going to divide by 84. And then we times by 100. Making sure to use the calculator correctly here. Not sure what exactly went on there. There we are. And we got our answer here of 72,000. Again, getting a whole number or a number without lots of decimal places is usually a very good sign you've got the right answer. So here we've got 72,000. Then we do a double sense check here. So she had 72,000. We take off 16%. Does that give us roughly 60,480? Yes, it does. Talking about 15% off here. So always use that double sense check to help you getting that right answer. Now, Sachin and Britta do have some savings accounts as well, which we're going to look at in this particular question. So Sachin opens it up with $1,500 on the 1st of January, and it pays 1.8% per year simple interest. So we've seen that phrase before in the previous question, and we want to work out that he has 1,581 at the end. So the first thing we're going to do is work out 1 year simple interest. That's going to be the first thing that we can calculate here. And the way that we do that is find 1.8% of $1,500. Now remember, 1.8%, if we take that over here, if we convert that into a multiplying decimal by dividing by 100, that's going to give us 0.018. So to work out 1 year's interest, we take 1,500 and then times by 0.018. So we can pop that into the calculator, and that's going to give us 27. However, we want 3 years of interest here. So 3 years is going to be taking that previous answer and then just timesing that by 3, which then gives us 81. Therefore, the total in the count, so total after 3 years, will be the initial 1,500 deposit plus this $81 of interest, and that gives us 1,581. It's always so satisfying in a question like this to have a show that question where you do get to the correct answer at the end. Britta also has her own savings account, and now it's the very first time we get to actually look at something called compound interest. Essentially, we get interest on the interest. So that's the key idea here. And the account pays 2% this per year, and Britta pays $500 into her account on the 1st of January every year. So that's going to change slightly the calculations we're going to do. So find out who has the greater amount, so Session or Britta, at the end of the 3 years and give the difference correct to the nearest cent. So the first thing we need to do is work out how much Britta has after 3 years. So in this kind of problem, we can just structure this by working out the first year, and then the second year, and then the third year as well. So there is a formula for compound interest we need to be aware of. Remember, if we're increasing by 2%, well, 100% plus 2%, that's equal to 102%. And if we divide that by 100, we then get the multiplier, which is really important here, of 1.02. So the first year, we're going to do 500 times 1.02. That will then give us the total amount that Britta has in her account after 1 year. So that gives us then, if we do that calculator, $510. Now we have to read the question carefully. So she pays in 500 into her account every year. So for the second year, we're going to have 510 from the last year. We're going to have 500 from this year. That gives us 1,010, and we're going to times it by 1.02 again. Having this structured approach makes it much easier for the examiner to give you all the marks. So we times that by 1.02. This time we get 1,030.20. Then the third year, again, we add another 500. Again, the 1st of January, that always is happening. So we get 1,530.2 times 1.02. Again, pop that into our calculator, and we will get 1,560.804. So that's our final amount after 3 years. Remember, Sachin, if we go back, he made $1,581. So the difference between that, so we're going to take away 1,581 from the answer we just got, and that gives us 20.19. Again, we want to do it to the nearest cent here. So 20.196, rounded to the nearest cent will be 20.20. So $20.20, and it is Sachin that's got more than Britta in this case. So Sachin has got the most amount of money, but only by $20.20. Okay, so you can check through all the questions that we've gone through so far. So I'm going to have a good big 10 marker, and you can see the same skills are coming up here. This reverse percentage change, the use of the 3-step procedure, knowing the difference between simple interest and compound interest, and we're going to reinforce that as we go through the next questions. Question 14 here, these are the first 4 terms of a sequence and we need to write down the next 2 terms. So whenever you get a question like this for the next 2 terms, the first thing you want to be thinking here is look at the difference between the numbers. So notice to go from 29 to 22, we need to minus 7. To go from 22 to 15, we also need to minus 7. And then to go from 15 to 8, we also need to minus 7. So to find the next 2 numbers, we just need to keep minusing 7 each time. So let me draw that in red. And then we just need to work out what calculation that is. Well, 8 minus 7 is equal to 1. And 1 minus 7 is equal to minus 6. Again, you've got a calculator if you need to check those as well. So our answer is going to be 1 here and minus 6. Now, the second part of the question, these are the first 5 terms of another sequence. So 4, 7, 12, 19, 28, and we need to find the nth term. And just like we did in the previous question, what we should start with here are the differences. So let's look at the differences here. So we've got 4 to 7, well, that's going to be plus 3. Going from 7 to 12, that's going to be plus 5. Then we've got 12 to 19, that's plus 7. And then 19 to 28, that's equal to plus 9. Now in this case, we've actually got a difference of a difference. Now what do I mean by this? Well, let's do the same thing we just did in the previous question with our differences. So how do I go from 3 to 5? Well, that's equal to 2. 5 to 7, that's equal to 2. 7 to 9, that's also equal to 2. And when you get this so-called second difference, and we'll see lots of questions like this today, so a second difference, you know there is something to do with n squared in our nth term. If there was a third difference that we'll see later on, then it'll be n cubed in some way. So because we have a second difference, there's going to be an n squared in some way. Now the first step that we need to do, and we always do this for a quadratic, this is what this is called, the n squared, we take that 2 that we just worked out and we divide by 2. So for quadratic, we always divide by 2, and we'll just quickly do that calculation here. So if we do 2 divided by 2, that's equal to 1. And what this tells us is that we need to write down the 1n squared numbers. Okay, so I'm going to write this sequence out that we've got at the top here, 4, 7, 12, 19, 28. And what I'm going to do now is write down the 1n squared numbers, also known as just the square numbers. So what is 1 times 1? That's 1. 2 times 2, that's equal to 4. 3 times 3 is equal to 9. 4 times 4 is equal to 16. And 5 times 5 is equal to 25. And once I've done that, I'm going to take the sequence from the bottom here away from the top sequence. So what do I actually mean by this? So let's work this out. So 4 minus 1 is equal to 3. 7 minus 4 is equal to 3. You can see the pattern here. 12 minus 9 is equal to 3. And you see we get 3 each time. Now, why have we done this process? Well, we can bring everything together. Notice this is just plus 3. In order to create our nth term, we just take the n squared from before and what we've worked out here, which is the plus 3. And putting that together gives us our nth term. So our answer is going to be n squared plus 3. Now, if this is slightly confusing at this point, we're going to do lots and lots of questions on this. So there'll be plenty of chance of practice. Those are the answers there. Again, this OE, by the way, means or equivalent. So say I wrote 3 plus n squared, and that is also correct as well. You can also see where you pick up the method marks. On to question 6. So the nth term we're given this time is n squared plus 3n, and we want to generate a sequence. We want to find the first 3 terms. So the way we do this is we just substitute in 1, 2, and 3 into our nth term. So let me show you what this means. So the first thing we're going to do, wherever we see an n, we're going to replace it with a 1. So we get 1 squared plus 3 lots of 1. Let's just calculate this. So 1 squared, 1 times 1 is equal to 1. 3 times 1 is equal to 3. And so the first number of the sequence is going to be equal to 4. Now we do exactly the same process, but instead of having an n here, we're going to put a 2. So we get 2 squared plus 3 lots of 2. So if I use the highlighter just to show what's going on here, so the 1 here and the 2 here, this is just replacing the n each time in our nth term. So if we do this, 2 squared is equal to 4. Again, you've got a calculator to work this out. 3 times 2 is equal to 6. Remember, BIDMAS, timesing first, then adding. And then 4 times 6 is equal to 10. And again, we can do the same thing with 3. So we get 3 squared plus 3 lots of 3. 3 squared is equal to 9. 3 times 3 is also equal to 9. And therefore, we get our third term of the sequence. So this is what we've been trying to look for, these numbers here. So 4, 10, and 18, which we're going to write over here, like so. And now we've got the first 5 terms of a different sequence, and we're going to find the nth term of this sequence. And again, the first thing that we do here is check the differences. So here, 25 to 18, that's going to be minus 7. 18 to 11, minus 7. 11 minus 4, going down in 7s. And so when we get a first difference that's the same, this is actually easier to work out. So our nth term is equal to minus 7, so that comes from the difference. We put an n next to it, it's an nth term. And then we think to ourselves, let's take that minus 7. What do we do to the minus 7 to get to the first number, 25? So imagine you have minus 7, here's 25. What do we have to add here in order to get to that number? And in this case, we need to add 32. You can check that, of course, on your calculator. So our final answer here is minus 7n plus 32. So when you have a first difference that's the same, this is quite a straightforward process. You saw in the previous question with quadratics that when you have a second difference, it can be a bit more complicated. Okay, you can check the answers. Notice I wrote this the other way around, which is absolutely fine because of the OE, or equivalent. Okay, and on to the next question. So this comes from a paper 4 rather than a paper 2, so it's going to be a little bit more involved. So these are the first 4 terms of a sequence. Write down the next term. Well, let's see what's going on here. Well, this is going down in 4. 11 minus 4 is 7. 7 minus 4 is 3. 3 minus 4 is minus 1. So if we minus 4 again, think of it like temperature. It's minus 1 degrees. It gets 4 degrees colder. Then that's going to be minus 5. And this is an interesting question. I haven't seen many like this. So write down the term-to-term rule for the sequence. So all they're asking for is what's happening each time. So all I need to do is write down that we are subtracting 4. That is what's known as the term-to-term rule, just subtracting 4. Now the nth term we do just like the previous question. So first of all, we take that minus 4, we put an n next to it, and then we look at that difference. So we look at the minus 4, we look at the 11, and then we say to ourselves, what do you do to minus 4 to get to plus 11? Well, that's going to be plus 15. So this is where that 15 comes from. I'm thinking in my mind here, what do I do to minus 4 to get to 11? Well, that's going to be 15. So that's our answer, minus 4n plus 15. On to part B of this question. So the nth term of a different sequence is 2n over n plus 1, and we need to find the difference between the 5th term and the 6th term. So let's work out the 5th term and the 6th term first of all. So the 5th term, the way we work this out is wherever we see an n in this calculation, we put a 5. So we will get 2 lots of 5 over 5 plus 1. And if we do that calculation, 2 times 5 is 10, and then we get 5 plus 1 is equal to 6. Now we do exactly the same process with the 6th term. So wherever I see an n, I'm going to put a 6. So we get 2 lots of 6 over 6 plus 1. If I use the highlighter here, So this is what I'm replacing here, the n with a 6. And if we work out that calculation, we get 12 over 7, like so. Now at this point, it wants us to work out the difference between them, so the difference between the 5th term and the 6th term, and we want to give the answer as a fraction. So what it's asking for, and you can do this either way round, we've got 12 over 7, and we want to find the difference between that and 10 over 6. So you can write it both ways round, 12 over 7 minus 10 over 6, or the other way round. Now the reason we're going to do this is now we're going to find a common denominator. The easiest way to do this is do 7 times 6, which is 42. So we're actually going to do some fraction work here, which is always useful. And now we work out what we need to do in the numerator. So we times 7 by 6 to get 42. So we need to do the same to the top. So 12 times 6, that's going to be equal to 72. Again, check this on the calculator. What do we do to 6 to get to 42? Well, we times by 7. So 10 times 7 is equal to 70. And now we can just minus the fractions by minusing numerators, the top numbers. That gives us then 2 over 42. Now I'm sure that would be fine for the answer, but again we can simplify this by dividing by 2 top and bottom to get 1 over 21. So our final answer here, and we always want to simplify if we can, is equal to 1 over 21. Now on to the last question here, is 3/4 a term in the sequence? Now the way we generally do this is as follows. So we take the nth term, so 2n over n plus 1. We make it equal to the number we're looking for, so 3 over 4. And then we want to find, is n an integer or a whole number? If it's a whole number, it's in the sequence. If it's not a whole number, it's not in the sequence. So that's our strategy here. Now the easiest way of solving this is using cross multiplying. So we're going to do this times this and this times this. This is a technique you've seen in many of my videos before. So 4 times 2n is equal to 8n. 3 times n plus 1 is 3 lots of n plus 1. And at this point, this is just an equation to solve. So we're going to expand the bracket on the right-hand side using the hook. So 3 times n is equal to 3n. 3 times 1 is equal to 3. Then we want to get all the n's on one side. So what's the opposite of plus 3n? Well, we're going to minus 3n on both sides. 8n minus 3n, that's equal to 5n. This cancels, this is what we wanted. So this is equal to 3. And you can probably see n is not going to be a whole number here. To work out what n is, the opposite of timesing by 5 is dividing by 5 on both sides. This cancels. We're left with n is equal to 3/5. And this is not a whole number. So it's a decimal, not whole number. So 3/4. I'm going to be really clear to the examiner here. Not in sequence. So the examiner can see very clearly that I've made this conclusion. 3/4 is not in the sequence. Okay, so you can check through that answer there. This comes from a paper 4, so as you can see it's a little bit more detailed. And on to question 5a. So the nth term of a sequence is 60 minus 8n, and we want to find the largest number in this sequence. Now the first thing to notice, because we have a minus 8n here, it is a decreasing sequence. So if we find the first term of the sequence, that is going to be the highest number that it can be. And the first number in the sequence is going to be when n is equal to 1. So I'm going to copy out this nth term, and wherever I see an n, I'm going to put a 1. So we get 60 minus 8 lots of 1, which is just going to be 60 minus 8, which is 52. Notice every number after 52 is going to get smaller, and therefore this will always remain the largest number. Now here are the first 5 terms of a different sequence, and we need to find an expression for the nth term. Again, always the first thing to do here is look for the difference. So here we've got a plus 7, here is also a plus 7, this is also a plus 7, and this is also a plus 7 as well. So to find an expression for the nth term, again, we do it in a similar way to what we did before. We have 7n, because we have an nth term. And now what do we do to the number 7? So this 7 here, to get to the first number 12. So to visualize this, we've got 7. We want to get to 12. What do we add on? And that's going to be add on 5. So our final answer is going to be equal to 7n plus 5, like so. Again, you can check the solution there. You can see they've written in exactly the same way. And on to the next question. This is a little bit trickier. So here we want to find the nth term of each sequence. This is towards the end of the paper. Again, we always look at that difference. So here we've got a plus 7. And see the differences get a little bit tricky here. So if you need to use a calculator at any point, that is absolutely fine. So here we're going to have a plus 19. At this point, we want to find the difference between 34 and 70. That's going to be 37. And then 132 minus 71. Again, you can always just work this out old-fashioned way using the standard methods, and then we get plus 61. Now we look for the next difference. So here we've got a plus 12. Then we have a plus 18, and then we've got a plus 24. So we don't even have the same second difference, but when we get to the third difference, notice we get plus 6 each time. So in this case, this doesn't come up that often. This is a third difference, so the sequence has something to do with n cubed. Now, the first thing we need to do when we get a cubic sequence, I'm going to do it over here, is we take the 6 of our difference, and because it's a cubic sequence, we divide by 6. This is worth remembering. That's equal to just 1. So what I'm going to do here at the bottom is I'm going to write down my sequence, and I'm going to write down the cube numbers, the 1n cubed numbers. So that's 1 times 1 times 1, which is 1, 2 times 2 times 2, that's equal to 8, 3 times 3 times 3, that's 27, 4 times 4 times 4, 64. Again, you can use your calculator for this as well. And I'm going to subtract, like I did earlier, one sequence away from the other. So 8 minus 1 is 7, 15 minus 8 is 7, 34 minus 27 is 7. Notice we get 7 each time. That's very, very helpful. So we get a plus 7 here. And so our nth term is going to be built up by the n cubed here and the plus 7 together. So even cubic sequences, you can do in exactly the same way as how I did the quadratics as well. Here we have a slightly different question. So first of all, we have the numerator and denominator. So we're going to treat this separately. The first one we have 2, 3, 4, 5, 6. So we're adding on 1 each time. So the numerator is going to be easier to work out. So our nth term for the numerator is going to be 1n, or just n. And then what do we do to 1 to get to 2? Well, we add on 1. So the nth term of the numerator is straightforward here. It's just n plus 1. What's a bit trickier is the bottom part here, because this is the first time we've seen what's called a geometric sequence. Notice we're timesing by 4 each time. Now there is a formula for the geometric sequence, so when you get timesing or dividing, and the way that we work this out is this formula here. So a r n to the power of n minus 1, where a here is the first term, and the r here is what's called the common ratio, so what we multiply by each time. So if we use it for this particular question here, the first term of our sequence is 1, so it's going to be 1 times, r is equal to 4, and then we get to the power of n minus 1. And the way we always approach fractional nth terms is we do the numerator separately as an nth term, and then the denominator separately as an nth term as well. So you can see the answers there, exactly the same as what I got there, and where you're picking up those method marks. Let's get started. So we've got a past paper question, question 8. A is the point -3,5, B is the point 5,2, and we need to find the midpoint of the line AB. A common question that comes up both paper 2, paper 4. In paper 4 it'd be a sub question, and we need to find the midpoint. So the way that we do this is we're going to find the average, the mean average of the x coordinates and then the y coordinates. So let's do the first part. We've got -3 as our x coordinate and 5 as our x coordinate here. So we are going to add them together. So -3 plus 5 and then divide by 2. Remember, to work out the mean of two numbers, you add them together and divide by how many there are. If we do that process, then -3 plus 5, that's equal to 2, and 2 divided by 2 is 1. So that's going to be our x-coordinate for the midpoint, and now we're going to do exactly the same process. Let's get a different colour here. Let's get a nice blue, and we'll pop that in to do the same process. So we take the y-coordinates now, so we take the 5 and the 2, and we're going to find the average of those. So we're going to do 5 plus 2 divided by 2. Well, 5 plus 2 is 7, and then 7 divided by 2, again, you can check this on the calculator as well. That's going to give you 3.5. So we have our x-coordinate 1 and our y-coordinate 3.5. So then we just pop that in. Notice it is a 2-mark question, so you should be showing some working for your answer. So there we are. We've got 1 and 3.5, and you get 1 mark for each there. Okay, on we go to a trickier question here from paper 2, and a kite is drawn on a coordinate grid. The diagonals of the kite intersect at the point -2, 5. So this word intersect we're going to see quite a lot. It means where the two lines cross. So you're not sure about that word, then do make sure you know that. If you need to know about more other trigger words, then check out the video above. One of the diagonals, and we'll draw a diagram to show what's going on here, has equation y equals 4x plus 3. Find the equation of the other diagonal of the kite in this form y equals mx plus c, which we're going to be working with quite a lot. So if I'm ever stuck with a worded question like this, I'm going to draw a diagram. So I'm going to draw what a kite looks like. Now, if we draw a kite here, again, I'm just going to draw a nice big diagram just to show you what a kite looks like. So make sure you know what these shapes are. And what the question is saying here is that if we connect up the diagonals, so let's connect up this diagonal and this diagonal, they cross, so this intersection point, that is at -2, 5. Notice as soon as you start drawing a diagram, it starts to make a lot more sense. One thing to remember about a kite, which is often forgotten about, is that these diagonals actually meet at a right angle, which is going to be very important for this particular question. Now we're told that one of the diagonals, again, let's just take one as an example here. Let's imagine this is the one they're talking about. Again, not to scale. Okay, this is y equals 4x plus 3. And we want to work out the equation of this line instead. Well, if we have two lines that intersect at a right angle, you need to be thinking immediately this phrase here, a negative reciprocal. This is something we're going to be using a lot in this particular video. So what do I mean by this? Well, if we take this line, the gradient of this line, the steepness of it, is equal to 4. So if we want to find the steepness of this line here, knowing that it's perpendicular, i.e. a right angle to the previous line, then we know that at least the first part of this equation will be equal to y equals -1/4 x, and then plus some y-intercept constant c. Now, where did this -1/4 come from? So I've taken the 4, I've made the reciprocal of it, which is 1/4. So you turn it into a fraction, 1 over it. And because we want a negative reciprocal, we can put a minus in front. Some of you may have learnt this rule here. m1, m2 is equal to -1. Again, that also works as well, because if we substitute the first gradient for 4, notice we'll get m2 then is equal to -1/4 if we solve that very small equation. So we've worked out the first part of this, which is the gradient of this particular line. And now all we need to do is work out this C, which represents the y-intercept, where it crosses the y-axis. Now the way that we do that is use the shared point from the two lines. So we're going to substitute for x first, minus 2, and y minus 5. This will allow us to then work out the plus c. So let's write it nice and clearly for the examiner. When x is equal to minus 2, y is equal to minus 5. And wherever I see a y, I'm going to put a minus 5. Wherever I see an x, I am going to put a minus 2. And now this is just an equation to solve. This is where we have to be nice and accurate. So first of all, we're going to do minus a quarter times minus 2. Well, the minus times the minus is a plus, and a quarter times 2 is 2 quarters. Again, you can do this on your calculator, or a half. And so if we want to get c on its own, what's the opposite of adding a half? Well, minusing a half on both sides. That then gives us minus 5.5 is equal to c. So our answer will be y equals minus a quarter x minus 5.5, but we don't generally write it as a mixed number. We generally write it as an improper fraction. So if we want to convert 5.5 to an improper fraction, we do 5 times 2, which is 10, add the 1, that gives us 11 on the top, and we keep the 2 the same at the bottom. This is generally a good way of keeping your straight line in terms of an improper fraction. This will help you when you get on to A level and IB. So our final answer is minus a quarter x minus 11 over 2. Again, you can check your answer here. Notice this phrase here, I've talked about this in previous videos. This is or equivalent. So what that means is if you wrote, for example, y equals, so some of you love decimals out there, minus 0.25x minus 5.5, for example. Now, some of you work in decimals, then that's absolutely fine as well. You'll get all 3 marks. On to our next question, which is a paper 4 style question. So there's lots of subparts as we go through. The first part is a little twist on what we've seen so far. So AB is a line with midpoint M. A is the point 2, 3. M, so the actual midpoint now, is 12, 7. And we need to work out the coordinates of B. So imagine you've got a coordinate, 2, 3. Imagine you've got the midpoint, which is 12, 7. And then you want to work out what this point B is. So I tend to like visualizing these kind of problems. You're going to see that kind of method as we go through. So imagine I connect all these up in a nice straight line. Well, then I look to myself, well, what's the gap between 2 and 12? Well, I need to add 10. So because this is the midpoint, I need to add 10 again. And that's going to give me 12 plus 10, which is 22. And I do the same trick here. So what do I add to 3 to get to 7? Well, add 4. So I need to add 4 to that. And 7 plus 4 is equal to 11. So by drawing a diagram, you can make your life much easier with these kinds of questions. Try not to learn just formulae off by heart. Again, visualizing the problem is going to help you in those A-level studies and IB studies afterwards. And now, from this, somehow, we need to work out that the equation of the perpendicular bisector, we're going to see this a ton on this particular video, is this equation over here. Right, so as soon as I see perpendicular bisector, I want to get everything set up. So remember A again was 2, 3, and then B was 22, 11. So this is what we're focusing on for this particular question. Again, we've got the midpoint, which we'll come back to later on. So keep that in mind. As soon as I see perpendicular bisector, so I see that phrase, there is a 3-4 step procedure which will work it out for you. The first thing that we need to do is work out the gradient, the steepness of AB. Now you can draw this visually. I'm going to teach you a formula on this one which is going to make your life easier, and that is y2 minus y1 over x2 minus x1. In other words, the change in y over the change in x. And the key thing here is not to get confused which one is which. So I tend to do a bit of highlighting here to make our life a bit easier. So if we take the 2 and the 22, so the x part of it, that's going to be our, and it doesn't matter which way round that we do this, this is going to be our x1, and that's going to be our x2. And then 3, so let's get the highlighter out and use a different colour. Yeah, let's use blue. So you've got 3 and 11. That's going to be then, the pen out, y1 and y2. So labeling those coordinates is really, really important so you don't make mistakes in working out the gradient, the steepness of the line. So if we do this and follow this, so we get y2 is 11, y1 is 3, and then x2 is 22. I'm just being very careful here. And then x1 is 2. So if we work this out, 11 minus 3, that's equal to 8. And 22 minus 2 is equal to 20. And you should always simplify your fractions when you get the chance. Notice 4 goes into both here, so we're practicing other skills from the course. So we're going to divide top and bottom by 4 to get a simplified fraction. 8 divided by 4, that's equal to 2. 20 divided by 4, how many 4s in 20? That's going to give you 5. So the first step is to work out the gradient. Now step 2 would normally be to work out the midpoint, but we already have that in the question, which is very useful. So I'm going to write it down again. So our midpoint here is 12, 7. We'll come back to that in a moment. Step 3 is a step that we've already seen in the previous question. Because we're looking for the perpendicular at right angles, bisector, we want again that negative reciprocal. Again, you're going to hear that phrase a lot. This is slightly different to the previous question because our gradient, what we need to do, because we already have a fraction, is we're going to flip that fraction and then turn it negative. So we're going to take the 2/5, we're going to flip the fraction, so that gives us 5 over 2, and then make it negative. So that gives us the gradient of the perpendicular bisector. So what that means is that y is equal to minus 5 over 2x plus c. Very similar to how we did that kite question earlier. Now, because we've got a bisector, it wants to go through the middle. Wants to split the line into 2 equal parts. Therefore, we know that the perpendicular bisector and the original line, they share this midpoint 12, 7. So we can substitute that in to work out the c. So let's do that over here. So when x is equal to 12, because that's the x part here, then y is equal to 7. We pop that in, so we get 7. So I'm just copying this equation. Wherever I see a y, I put a 7. And wherever I see an x, I'm going to put a 12. And now it's a case of making c the subject. So if we do this part here, you can do this without a calculator as well. Well, notice that you can actually cancel here. So 12 divided by 2 is equal to 6. Minus 5 times 6 is equal to minus 30. And therefore, if we want to work out c on its own, what's the opposite of minus 30? Well, adding 30 on both sides. That gives us then 37 is equal to c. So our answer in y equals mx plus c form is going to be y equals minus 5 over 2x plus 37. Now you might think that's the answer at this point, but notice they want it written in this kind of strange way over here. So we have to do a little bit of massaging to get it in the form that they want. So let's create a little bit of room for ourselves. So we've got plenty of space to do this. So I'm just going to copy this across. So minus y equals minus 5 over 2x plus 37. Again, I like to call this massaging, just massaging it so we get it looking like the box here. Now, the first thing I notice is we actually have a 2y, not a single y. So the first thing that comes to mind is, let's just multiply everything by 2. Because that's going to guarantee us that we get 2y, because 2 times y is 2y. The times 2, well, that's going to cancel with the 2 down the bottom. That gives us minus 5x. And don't forget to multiply this 37 by 2 as well. 37 times 2 do it on your calculator, is 74. And suddenly we get something very, very similar to the box, but we just need to do one tiny thing here, which is bring the x over to the other side. So what's the opposite of minus 5x? Well, plus 5x on both sides. That's going to give us 2y plus 5x is equal to, well, that cancels. So we get 74. And it's a great feeling in the exam when this happens, because you know by getting to the correct answer here, you have guaranteed all 4 marks for this particular question. And remember, this is a paper 4 question, so it's going to continue as we go through. So just to remind us, the perpendicular bisector, so I'm going to put PB, is what we just worked out. So 2y plus 5x is equal to 74. Super. So the perpendicular bisector of AB passes through the point N. The point N has the coordinates 2, n. Find the value of n. So we're given the x coordinate here. So we're told the x coordinates, and it wants us to work out the y coordinate. So when x is equal to 2, we're going to copy out what we've just done. Wherever we see an x, we're going to put a 2 and then solve. So we get 2y plus 5 lots of 2 equal to 74. And now we just need to work through the algebra. So we have 2y plus, well, 5 times 2 is 10 is equal to 74. And when you get to this stage, it's nice and relaxing getting through to y. So we're going to minus 10 from both sides. Again, the opposite operations here. That gives us, this cancels, 2y is equal to 64. And then the opposite of timesing by 2 is dividing by 2. That's going to give us then y is equal to half of 64, which is equal to 32. So a 1 mark question. Again, if you can get to the answer directly without showing that working, that is absolutely fine as well. Right, so now we've got, again, slightly different question. They do this often on paper 4s. You know, the first part, A, B, C, will be quite straightforward, but then D will be a little twist on what you've seen on the course. And points A, M, and N, they form a triangle, and you need to work out the area of the triangle. Whenever you get a problem like this, you're like, I'm not sure where to start with it, draw a diagram. Doesn't have to be the scale in the slightest. So let's go through our points. So A is 2, 3. So I'm just going to write down these points. M we worked out before, didn't we? It's 12, 7. And then N is equal to 2, 32. First thing I notice here is that the x coordinates are the same for A and N, which is going to be very useful a bit later on. So let's draw a diagram here that looks reasonably accurate. Again, doesn't have to be to scale in the slightest, but to give us a good idea of what's going on. So A is 2, 3, so that's going to be somewhere here. N, notice, is 2, 32, so it's on the same horizontal line, just way over here. And then M is going to be 12, so in the middle somewhere, not exactly in the middle, that doesn't matter. And then further up, so other way round. So we've got 232, so let's do this again. So the x coordinates are the same, and it's the y that differs. So we've got n way up here, and then we've got 12, which is over here, and then 7, which lies closer to this point, but again, it doesn't really matter. So we get a triangle. What's crucial here, and the first thing I notice in this question, this is A, this is N, this is M. This is a straight line upwards, which is going to make our life a lot easier actually calculating the area. Remember, the area of a triangle is the base, so this is going to be our base in this case, multiplied by the perpendicular height divided by 2. So let's work out these things. So our base is going to be the difference between 3 and 32. So that's going to be 29. This perpendicular height of it, well, it's going to go from 2 and it's going to go all the way to 12. So that's going to be 10. And that's all we need here. So in order to work out the area of the triangle, we're going to do a half 29 times 10. So again, we can do that on the calculator if you so wish. We can do a half of 290, Don't need a calculator though, that's going to be 145. So our final answer, again, it's all about drawing a diagram that makes sense. It's going to be 145. Notice there are no units in this particular question, so you don't have to put a square centimeters or square meters. Again, the diagram is really helpful here, and spotting that two of the points share the same x or even y coordinate would also work in the same way. That means that you can form a very easy equation then to solve to work out the area of the triangle. Okay, so you can check your answers here. Again, it's a very bizarre method that you could have used for part D, but I think drawing the diagram, visualizing, using that knowledge you've got from the course is a much easier method. All right, and let's continue on to a more difficult style question. Now notice when you get a question number here on paper 4, this is question 11, question 12, towards the end of the paper, they generally are on the harder side. Whereas you're going to see later on question 3, that'll be a slightly easier style question. And we've got a triangle here, and we need to use the cosine rule. So we'll go back and check what the cosine rule is to show that this quadratic is true in some way. So we've got quite a lot of work to do here because it is out of 4 marks. And let's just remind you what the cosine rule is. So it's equal to c squared equals a squared plus b squared minus 2ab cos c. Now remember the formula sheet actually had the letters in a different way around, but let me just show you how these letters correspond to my diagram. So the angle is going to be big C, so this one here. The side opposite big C is going to be small c, and then the other two sides, it doesn't matter which way round, are going to be A and B, like so. So now I've labelled the sides, I can now substitute A, B, small c and big C into my formula. So I'm going to copy out the formula. Wherever I see a small c, I'm going to put a 9. Wherever I see a small a, I'm going to put a 3x minus 1 and so on. So let's do that now. So we get 9 squared equals a squared is 3x plus 1 all squared plus, and this be very careful with brackets here, so 2x all squared, because we're squaring the whole of 2x here, minus 2 times, well, a is 3x plus 1, so 3x, so minus 1, sorry. Can't read my screen, that's not very helpful. Good, I'm always checking these things though. So 2x times the cosine of the angle, well, the angle is equal to 60, like so. So let me change this, because this should be a minus 1 here. So that's important. And now let's work some of these things out. Well, 9 squared is equal to 81, so that's fine. 3x minus 1 squared. Now remember, that's the same as timesing it by itself. So 3x minus 1 times 3x minus 1. And now we're going to use FOIL. So that's first, outside, inside, last, to make sure we multiply it out correctly. So 3x times 3x is 9x squared. 3x times minus 1 is minus 3x. 3x times minus 1 is minus 3x. And then minus 1 times minus 1 is plus 1. Make sure you're very careful with that last one there. If we collect up the like terms, then we get 9x squared, that stays as it is, minus 3x is minus 6x, and plus 1 stays the same. So let's pop that in now. So 9x squared minus 6x plus 1. Now 2x all squared, remember that's the same as doing 2x times 2x, and that's equal to, well, 2 times 2 is 4, x times x is x squared. So let's pop x squared here, 4x squared. And now let's neaten this out. So here we've got 2 lots of 3x minus 1 multiplied by 2x multiplied by the cosine of 60. Now this is one of these exact values that you should know off by heart. Of course you can always use your calculator to check this as well, but the cosine of 60 is equal to a half. Now on a calculator paper this is obviously not that important. Let me just quickly show you. So trig cos 60 is equal to a half. So you can see you can use your calculator, but if you know them, it will speed up the process quite significantly. So go times a half, like so. Let's keep simplifying this down. So 81 I'm going to leave alone for the time being. Notice we've got a 9x squared and a 4x squared, so that becomes 13x squared minus 6x plus 1. And now we're going to work out the bracket. So we'll do this in stages. Well, 2 times a half cancels, because that becomes 1. So these cancel. So we're left here with 3x minus 1 multiplied by 2x. Just take it one step at a time. And let's keep going. So 81 equals 13x squared minus 6x plus 1. And now we're going to expand the bracket. So I'll do this separately here so you can see what's going on. So remember, expanding a single bracket, we used our single hook, like so. So 2x times 3x is 6x squared. 2x times minus 1 is minus 2x. So let's pop that in. And this minus here is very important. So we need to be very, very careful how we deal with this. And we're almost there. We're almost there. So once you see this next step, you'll see we've almost got to the answer. So we get 81 equals 13x squared minus 6x plus 1. And now we're expanding essentially a single bracket here as well with this minus. So we get minus 6x squared. And this is the thing really to watch out for in this question. The minus times a minus is a plus. So we get plus 2x. Oh, almost there. So 81 hasn't moved for the time being. So 13x squared minus 6x squared is 7x squared. Minus 6x plus 2x is minus 4x plus 1. And this is where you're feeling quite confident because this looks almost identical. Let me just put the final answer up here, a bit of space. So I'm going to flip over the equation. So I've got all the x's on the left-hand side. And to get my very final mark here, well, I want to have the right-hand side 0. So what's the opposite of adding 81? That's minusing 81 from both sides. This is really satisfying when you get to this point. And you get 7x squared minus 4x squared plus 1 minus 81 is minus 80 equals 0. And the great thing about this is I know I've got the right answer. You see this, you see that, and then you go, yes, I've done it. I've got those 4 marks in the bag in this particular question, which is a pretty tricky question. It's certainly going to be grade A, for this kind of algebraic manipulation. So you can have a look through the mark scheme. The mark scheme is not very useful here because it doesn't show you all these intermediary steps that I did in the middle. So this is why these kind of videos are very, very useful. You can see exactly the process I've gone through to work out the answer. Right, let's move on to another question 11. So 2 question 11s. And in the diagram, ADC is a straight line. Now that is important a bit later on. But the first thing we need to do here is calculate AB. So as soon as you see this right angle triangle, you need to be thinking Pythagoras or trigonometry. Here we have one side and one angle, looking to find another side. So trigonometry is called for. Once we know it's trigonometry, then we have to label our sides. It's our first step that we do. So this here, this new x is opposite the angle. So this is O. This 8 here is next to the angle. So I'm going to put an A here. And again, we use SOHCAHTOA. So which of those has an OA in it? Well, that's going to be tan again. So we're going to use tan twice in this video so far. And again, we need to know these formula triangles. And this time we are looking for the opposite. So this is the thing that we don't know. So we cross out this part here. And then we're going to do the calculation we see, which is tan of the angle times adjacent. So to work out AB, we are going to do tan 34 times 8. So I've shown my calculation for the method mark. Let's go to my calculator and work it out. So we're going to type in, we can use TAN or we can press the trig button, tan 34 multiplied by 8, enter, and we get our answer of 5.396. So I'm going to write down 5.396 dot dot dot. And again, we want to round, as always, to 3 significant figures. So 1, 2, 3. We round the 9 upwards, so that's going to give us 5.40. Again, we have to be very precise in the rounding that we do to guarantee that we get all the method marks. Now we need to work out the angle DBC. And it's a whopping 5 marks, so you know there's going to be quite a bit of work involved in order to work out DBC. Now, how do I know where DBC is? Well, the middle letter always tells me where the angle is, and the sides tell me, okay, how do I get there? So DBC, it's going to be this angle that we're looking for here. Now, back to my point here, ADC is a straight line. Therefore, I know that these two angles, so this angle plus this angle, add up to 180. So to work out this angle here, I'm just going to do a very quick calculation of 180 minus 34, and that's going to give me 146 degrees. So I'm just going to pop that in. Again, always use a calculator if you're not sure about that calculation. And then we look at the problem here and go, well, we've got a side and an angle. We're looking for this particular angle here, but at the moment we can't work that out directly. However, we can use this side over here. We can use this 8 to help us work out this one. So if we go through the process again, we have an angle and a side. We have a side and then a missing angle here. What does that call for here? Well, there's no more SOHCAHTOA, there's no right angle triangle, so we're going to use either the sine rule or the cosine rule. This is a situation for the sine rule. Now, what is the sine rule? Well, this is on your formula sheet. Sine A over A equals sine B over B. So we just need to label this up correctly just so we know which one is which. So just to stop any confusion here, I would rub that out, but I can't. So let me use a different color. So we're going to make this our big A because we know we're going to make the angle that we don't know big A. So we're going to make this one big A. This makes this then small a, and then we're going to make this big B and then make this small b. If we label it correctly, it makes the working we're going to do just now a little bit easier for us. So let's go through this process. So we've got sine A divided by the side opposite it, so that's the 8 over here, and that's equal to sine of the angle here, so that's sine 146 divided by 19. And generally when I have this kind of problem, we want to try and get the A on its own, or the sine A on its own. So we look at the left hand side and go, well, what's the opposite of dividing by 8? Well, we need to multiply by 8 on both sides. This has the effect of cancelling here, so we get sine A is equal to, well, 8 times sine 146 is exactly that, divided by 19. And we can simplify this slightly further before we actually go on to use our calculator. So then we have the sine of the angle, so what's the opposite of sining? Well, that's going to be the inverse sine, and remember we do that to both sides. So that's going to give us A, because this part and this part cancel. And so we get the sine inverse of 8 sine 146 over 19. And notice I haven't rushed to my calculator here until I've got it in a form that I like and try and minimize any of those rounding errors as we go through the problem. So I'm going to go to my calculator and work this out. So where is the inverse sine button? Well, all you have to do is go to trig here and you'll find this a sine minus 1 button under here. So that's where our inverse sine function is. To make a fraction, we just go to control and divide. That gives us our fraction. And then we just type it in. Notice I can type in sin and it will recognize the function. I do love this TI Inspire calculator. And put 19 at the bottom. If we work this out, we get the angle of 13.618. So let me write that in. 13.618 dot dot dot. So that's the angle here. 618 dot dot dot. Now, of course, that is not the answer that we're looking for here. We are looking for the angle DBC. But now we can use the idea that angles in a triangle add up to 180 degrees. So to work out this final angle, so DBC, we just do 180 minus the two angles that we do know, so 146 plus 13.618 dot dot dot. Again, trying to avoid those rounding errors by keeping as many decimals in as possible. So let's go back to my calculator. So all I'm going to do here, I'm going to do 180 minus, open brackets, 146 plus answer, so control answer. This allows me to get the most accurate answer possible for this particular question. So if I work this out, I then get my final answer of 20.38. 20.38 dot dot dot. And of course we always round to three significant figures, so our final answer will then be 20.4 degrees for our 5 marks. Now I think maybe this should be a 4-mark question personally, but again there's quite a lot to consider here. First of all, the angles on a straight line, then using the sine rule for an angle correctly, and then realizing we need to use angles in a triangle to find our very final answer of 20.4. Now we're going to use this a little bit in the next question as well. So now we need to calculate the area of triangle ABC. Now just keep in mind here that the triangle ABC, so if I do this in a different color, let's do some yellow, is the entire triangle that we see in front of us. So it's this part, and this part here. So we try and find the whole triangle together. Now the easiest way of doing this is to use that formula from the formula sheet that we haven't mentioned yet. So the area is equal to a half AB sine C, where A and B are two sides and the C angle is in the middle. Now the one that comes to mind here is to use some of the things that we already have. So I'm going to use this big angle here as my angle in the middle, my C. As X we already worked out from the previous question, 5.40. We know 19 from the question itself. And because we worked out this angle, notice these questions lead into, we actually know that this angle here, the whole angle, is going to be 90 plus the answer we just worked out, 38 dot dot dot, which is going to be equal to 110.38 dot dot dot. So let's bring all this together for our formula. So the area of the triangle, I'm just going to write down to the examiner that I know what it is, half AB sine C. And let's just pop in all the numbers that we have. So half times, well, we know what X was. That was the 5.396 dot dot dot. We know that the B side would be 19, so times 19. And then times the sine of the angle in between. So that's 110.38 dot dot dot. Notice with this kind of question, they are usually quite lenient in if the answer is not exactly accurate, they'll still give you all 2 marks. Let's try and make it though as accurate as possible. So we have 0, oops, there we go. So 0.5 times 5.396. Probably should be using a few more decimal places, but we'll use this for the moment. 19 times, and we want to use sine here, of 90 plus answer, because the answer from before was that smallish angle that we had. So I'm trying to use that just to minimize any rounding errors. So I think we've got everything there, and then we get to our final answer of 48.052. 48.052, and that rounds then to 48.1. So let's just check the mark scheme, make sure that's accurate enough for the mark scheme. Yes, it is. You can see actually it should be between these two numbers. So both 48.0 or 48.1 is correct. But the best thing to do is try and keep as many decimals in the question as possible, just so you don't miss on any accuracy marks at the end. Notice with the mark scheme here, they give you a range to get it between. So 48.04 and 48.12, which we certainly fit into with our answer of 48.052. So again, try and keep those questions as accurate as possible. Right, on to our next question, so question 5. So the area of the triangle ABC is 34.1 square centimetres. Now as soon as I see this, I know that formula we looked at in the very last question, half AB sine C, is going to be useful in some way. We're given AB is 12.4, angle ABC is 30, and now we need to show that BC is equal to 11. So we're looking for this side here. So what I'm going to do is just use that area formula that we have. So area is equal to 1/2 AB sine C. And now let's just put in what we know. Well, these are the two sides A and B, and this is the angle in between, so C. So if we substitute this in, well, 34.1, that's our area of the triangle, is equal to 1/2 times, well, A is 12.4. B, we don't know, that's what we're looking for here. So I'm just going to call this X, because that's the side we're looking for, times the sine of the angle in between, sine 30. Now, I could simplify this down, because sine 30 is 1/2, and you can find half of 12.4. But what I'm going to do here is just let the calculator do this for me. I want to get the X on its own, so I need to divide by 1/2 times 12.4 times sine 30. Basically, I want all that on the other side of the equation. So divide by 1/2 times 12.4 times sine 30. If I do this, well, these all cancel. That leaves me just with X. And then I get 34.1 divided by 1/2 times 12.4 times sine 30. And now I'm going to let the calculator do the donkey work here and work out exactly what this is. So we type this in. So 34.1 divided by 0.5 times 12.4 times the sine. Always very satisfying when you put this in and you get the exact answer that you're looking for here, which is 11. So we're just going to pop that in, and that's equal to 11 centimetres, guaranteeing that 1 mark. Excellent. Now we're going to move on and work out AC. So let's have a look here. I now know this is equal to 11 centimetres, and I want to work out this length here. Let's just call that Y. So I look at the triangle I have here. I've got two sides. I've got the angle in between, and I'm looking for the side opposite. This calls for the cosine rule. Now remember, the cosine rule was c squared is equal to a squared plus b squared minus 2ab cos c. And now I can just substitute everything that I know into this. So we're looking for this side, so y squared is equal to, well, a squared and b squared, so 12.4 squared plus 11 squared minus 2 times 12.4 times 11 times the cosine of the angle in between, which is 30. And remember, I want to find y on its own. So what's the opposite of squaring? Well, I do need to square root on both sides. So notice I haven't reached for my calculator yet. I'm waiting until I get to this final step. So y is equal to the square root of 12.4 squared plus 11 squared minus, open brackets, 2 times 12.4 times 11 times cos 30. And you can pick up a lot of marks on these questions by just knowing these formulae and working through these questions nice and carefully and logically. So let's pop this into the calculator and see what we get. So we're going to start with a big square root. It's going to be a big square root by the end. So 12.4 squared plus 11 squared minus, this is where brackets are really, really important, so please do include them, 2 times 12.4 times 11 times the cosine of the angle in between. Okay, hopefully that's all enough brackets there. So always double check. So checking my working here on the left hand side, checking that with what I've just typed in. I press my enter button and I get my answer of 6.21. Okay, so let's pop that across. So 0.55 dot dot dot. Now usually I would write this working here in this space for B. If we round this, then we're just going to get 6.21 centimeters. So then always check your rounding for these kind of questions as well. Don't need to put units twice to get my answer of 6.21. And now we're looking for angle CAB. Remember that middle letter tells us where the angle is. So we're looking for CAB using the letters that are given in the question. So we're looking for this angle here. As soon as I look at this, I go, well, I've got a side and an angle, and now I know this side because we just worked this out. This was 6.2055 dot dot dot. So this calls for using the sine rule. So when you've got a side and angle and a side and you're looking for another angle, then we're going to use the sine rule. That's all about labeling here. So let's do a different color so you can see what we're doing in this particular question. So I'm going to call this big A. I'm going to call this now small a. I'm going to call this big B. I'm going to call that small b. Right, let's do it on this slide here. So we're going to go sine A over A is equal to sine B over B. So A we don't know, the side opposite is 11, so we get sine A over 11 is equal to sine of B, which is 30, divided by that side we literally just worked out, so that's 6.2055 dot dot dot. Again, we want to get the sine on its own, so what's the opposite of dividing by 11? Well, we need to times by 11 on both sides. If we do that, then we get sine A is equal to 11 sine 30 over that 6.2055. We're not quite done before we use the calculator. What's the opposite of signing something? Well, inverse sine on both sides. This gives us then A is equal to sine inverse, and then everything in that fraction. So 11 sine 30 over 6.2055 dot dot dot. Remind me to try and use as many decimal places as possible. Let's go and see what the calculator says. So we start with trig sine inverse. Open up our fraction. So we have 11 times sine 30, close brackets. And now I can use the answer from the previous question. So I can go control answer. That will then take this answer here that I've just used. Let's make sure there's brackets there. And then we get our answer of 62.413. 62.413. And that rounds then to 62.4 degrees. If you check the mark scheme again, that falls within that range that we've looked at here. That's absolutely fine. Notice I do try and keep it unrounded when I can, because it does give you the most accurate answer in case there are any problems with the accuracy there at all. And my last question is to find the length of the perpendicular line from A to the line BC. So this is a slightly different kind of question here. So let's go back to my diagram. So imagine I drop a perpendicular line from A to the line BC. So from A to the line BC. So this is what they mean. Imagine this is perpendicular. Now, as soon as you see that word perpendicular, you know that there are right angles there. So perpendicular, diagram's getting a bit messy now, basically means they meet at a right angle. Okay, so what I like to tend to do in these kind of questions is separate the problem just so I can see what's going on. So what I'm going to do is draw this triangle at the top here with the information that I know. So I'm going to rotate it round. Okay, so that's my right angle here. I don't know this length, this is what I'm looking for. I know the hypotenuse because it's opposite the right angle is 12.4. And I know that this angle here is 30, which is over here. So I've just done a quick 2D representation of exactly the triangle I'm looking for here. And once we know that, then we can simply use SOHCAHTOA, our classic. So let's get labeling those sides. Don't know why I put a degree sign there. There we are. So this is going to be opposite because it's opposite the angle. This is the longest side. And this time we're not going to use tan like we've done before because you've got O. So of SOHCAHTOA, which one's O? Well, that's going to be the SOH. So if we draw our formula triangle, we have sine theta times H and O. So we need to know these formulae triangles like literally off by heart. We are looking for the opposite. So we're going to do sine of the angle times H. So our answer for X is going to be sine 30 times 12.4. And you'll see that is 6.2. Now, how do I know that's 6.2 without using the calculator? It's because I know my exact values. So I know sine 30 is equal to a half. So it's just a half times 12.4, which is just equal to 6.2. No rushing to my calculator for that particular question. Again, I really do recommend if you need to know those exact values, then do check out the link just as you see above, because that goes through exactly how to work out sine 30, sine 45, cos 60, tan 45, and so on. So here's the mark scheme. Again, you can have a look and see what I've done and where I've picked up all the method marks for these particular questions.